and this is chapter number 4. We'll complete it today. We covered up to placement of sniffers. So what's the strategically best position to place your sniffer in order to get the best possible results that you can have. Now we'll proceed from here and we'll try to understand what are the other concepts in this one. We all know what is a MAC address. Media access control address is a unique identifier assigned to a computer associated with a NIC attached to most networking equipment. Distinguishes a computer from the other computers on the same network. Now what's happening is that each and every device, whatever goes on the internet, has a MAC address. Now MAC address is unique for all devices that we use. So if we are using a laptop, a desktop computer, mobile phone, or a tablet, each would have a separate MAC address. Now in order to find the MAC address, you'll go to the PowerShell on the computer, which is there in Windows 10. You have lots of exciting features on this one, and the commands that we pass on this one are called commandlets. Now these commandlets are predefined and they'll pull the relevant information which is required for your operations. Now if you want to find the MAC address of the computer, like for the MAC address of a computer, you can see it over here. It's written MAC address. Now if you are using virtual machine on your computer, you might see a Hyper-V virtual adapter available as well. Now it would have a separate IP address, separate MAC address, but that's just virtual. Same goes if you are installing VirtualBox or if you are installing VMware Workstation. The virtual adapters will have a MAC address which would be different than your host machine. Now data transfer over the network, if a data packet is sent from Alice to Bob, is just an example. It must pass through many routers. For example, if one Alice is sitting in one city and he's trying to or she's trying to send a message to Bob, it would travel through different routers before it would reach to Bob. Router first examine the destination internet protocol, like what would be the protocol for the destination, to direct the data packets to Bob. Now Alice has the information about the first router and the IP address of the Bob's PC. So it knows that once the traffic would leave my computer, that's the first hop, and then they know the address of Bob's PC. Alice's computer employs the Ethernet frame to communicate with that router. So it would encapsulate the traffic. Alice is sending a traffic from her computer through the internet to Bob's computer. As you can see that the IP addresses are different for Alice and Bob. Now the data transfer over the network continued. Alice is sitting, she is communicating through router R1, whereas Bob is sitting in some other state and the traffic would be routed back to him. The transmission control protocol, internet protocol, stack in Alice's computer. Now it generates a frame to transmit the data packets to Bob in Houston. TCP IP stack then transfers it to Ethernet module. Ethernet information is added to it that it should go to Bob. Data is sent so that the TCP IP stack at the opposite end is able to process the frame, and the CRC, which is cyclic redundancy check, verifies that the Ethernet frame reaches the destination without being corrupted. So it has encapsulated the data frame packet with the MAC address of Bob's PC so that it reaches only Bob's PC. We'll be covering it in another module which would be coming in a couple of slides. Frame is sent to the Ethernet cabling within the network or the private LAN or through the internet. All the hardware adapters on the LAN can view the frames, but they'll not communicate with it unless and until it is destined for that particular address. Every adapter then carries the destination MAC address in the frame in which its own MAC address. Now the role of a sniffer on a network is on a promiscuous mode. Now we'll have to understand what is a promiscuous mode. It's usually used in Kali Linux if you want to capture the packets of all the other networks. We call it in a managed mode. In a managed mode, so that you can manage it in a way so that you can capture the packets. The science of it is that if packets are sent to a specific computer on the network, it won't go to the other users, it would go to specifically that MAC address where it's intended to go. Other adapters, wherever the packet would reach, it won't accept it because it's not intended for that specific user. In promiscuous mode, what happens is that you will programmatically change it in a way so that it would capture all packets whatever are sent on the network, regardless if they are sent to the user or not. A NIC can retrieve any data packet being transferred throughout the Ethernet packet segment. Whatever packets are flowing on the network, it would capture them. A sniffer on any node on the network can record all the traffic that travels. So it is capturing or listening all the traffic. By using the NIC built-in ability to examine packets, a sniffer puts a network card into a promiscuous mode. By using a programmatically interface can bypass the TCP/IP stack operating system, and some sniffer programs are used for monitoring process. So sometimes they capture the packets, and then the same technique is used when they try to attack the Wi-Fi networks. That they put the network interface card in promiscuous mode, then they capture the packets, and then they disengage the client from the router and would take the packets in between. Partially functioned sniffers have fallen out of favor. Now we have Wireshark, and its old name was Ethereal, probably the most known and the most powerful free network protocol analyzer. So if you are capturing a packet between a source and a destination, you can filter it out by any protocol that you need to read in between. Just like we mentioned that telnet communication on the network is in a clear text format, so it's recommended to have a SSH session in between so that your communication is secure. Otherwise, if you capture packets using Wireshark on a network and someone is using a telnet, you can clearly see what packets went on the network. Even the username and password can be captured. Allows you to capture the packets from live network and save them into a capture file disk. Data can be captured off the wire from the network connection. Now TCP dump or Win dump, these are the two different names depending if you are using a Unix operating system or if you are using a Windows. Most commonly bundled sniffers with Linux distros, widely used as a free network diagnostics tool. Configurable to allow the packets data collection based on a specific string of regular expressions. Can decode and monitor the header data, Internet Protocol, TCP, UDP, and ICMP. So this information is usually available on the packet itself. Now IP is the Internet Protocol, then Transmission Control Protocol, and ICMP supports us for any kind of ping commands that communicate. If we are sending a ping command, the response that we receive is because of ICMP. Monitors are decoders. Application layer data can be used for tracking the network problems, detecting ping attacks, or monitoring the network activities. Ping attacks means that most of these hackers who are trying to get access to the machines, the first thing they must know if the client computer or the target computer is on or not. So in most of the cases on the network, ping is disabled so that you cannot see. No one can see that if the other machine is on or off. There are specific computers only which are allowed to ping other computers, so that for everyone it would appear as the target computer is off. Now commands is TCP dump for Linux and Win dump for Windows. Now snort is another utility which is used in intrusion detection system. It actually installs as a command line tool on the computer on Windows-based systems, and it monitors for any sort of intrusion. Just like I showed you malware anti-exploit, which helps us in detecting the people who are trying to penetrate on the other computers. Can be used as a packet sniffer or packets logger or network intrusion detection system, logs packets into either binary or ASCII format. Now, functions include performing real-time traffic analysis, performing packet logging in IP network, debugging network traffic, analyzing protocols, searching for matching contents, and detecting attacks such as buffer overflows, etc. It works on Linux, Solaris, Windows NT, 2000, Sun, and other operating systems. Now, Network Monitor, which comes in pre-installed with Windows, is a feature which helps you in identifying the problems on the network. It's a part of a Windows family. It came on Windows 2000, and then onwards it's available. You can have some third-party tools from SolarWinds as well in order to monitor basic traffic on the network, captures the network traffic, and translates it into a readable format which you can understand. Supports a wide range of protocols, maintain the history of each network connection, and support high-speed wireless networks and provide advanced capability. Now, Cain and Abel is another cracking or encrypting password tool using a brute force dictionary and cryptanalysis techniques, recording VoIP communications or conversations, recording the network keys, uncovering cached passwords, and analyzing the network protocols. It's available for free on the internet. You can install it, but you'll have to disable the antivirus completely before you'll install it, because your antivirus won't let it run, especially on Windows 10. So either install it on a virtual machine or on Windows 7 or an older operating system where you can disable the antivirus completely. It creates some issues where you'll be constantly getting warnings that this tool is not safe to run on Windows. So make sure if you're testing it, you're installing it on a machine where your antivirus and everything is completely off. Otherwise, they'll simply delete the application from there. As you can see, it helps us in checking the protected storage, LSA secrets, and then the wireless passwords, Internet Explorer passwords, dial-up passwords, and other things which are saved on the computer. So this kind of basic communication. There are lots of tools like this which is available on the internet, which helps us in investigating any machine which is being compromised. You can create a image of it, a virtual image of it, as we read in the computer forensics and investigation. You can create a complete image of it and then work on it, install any sort of applications that you have, just to see that what other techniques were used in order to penetrate in the computer. Now, Kismet is a wireless sniffer that detects the networks through a passive sniffing. There are lots of tools like that available, but the best tool in order to sniff the wireless networks is Kali Linux itself. But you'll have to have a alpha wireless dongle or a wireless device in order to capture the packets in promiscuous mode. Otherwise, usually the regular wireless adapters that we use or built in on the computers cannot be turned into a promiscuous mode. Now, Fluke Network Protocol Analyzer. Fluke Networks is a provider for the network tools. They have a set of tools available which helps us in identifying lots of problems on the network and tools which would help us in identifying the actual location of the cable. Just like you might have seen before in the PBX exchanges on the telephone, they usually use a beeper in order to find out the location of the cable. Now, the same thing is there. For example, if we have a RJ45 connector, a socket inside a room or in an office, now we don't know that where is it terminating actually. It becomes a big problem to locate it on a switch. So we connect a device over here which would keep on sending some signals, and on the other side we have a tracer, so we'll just trace it on the cables in order to see that where is the signal going. I'll show it in the lab session. We have a small device. It helps us in identifying and locating the cables. Otherwise, it's really difficult to locate a cable, especially if there is no labeling on the cables itself. The advantage of using an appliance, they have an appliance for the Fluke networks as well. Impossible to mishandle the installation of the software. It is dedicated appliance, but not used that much because you are relying on one thing for this thing, but for rest of the protocols which you need to analyze would be difficult. Locks you to an appliance designer architecture and vision, so you cannot do lots of other things. Now, detecting a sniffer, since the technology is passive, passive means that it's not noisy on the network, means it won't trigger any sort of alarms on the firewall because it's only reading it. It's difficult to detect. You can only detect whether or not the suspect is running his or her NIC in promiscuous mode. Tools available to check the sniffers in anti-sniff, sniff detect, and then promiscuous mode, etc. Now, the next generation firewalls that we are using, especially Palo Alto, we can completely disable sniffing and stuff like that through the firewall itself. We can even check or set alerts if there are any sniffing attempts going on the network. DNS Test, some sniffers perform DNS lookups in order to replace the IP address of their logs with fully qualified host names. Or we can call it FQDN. What is an FQDN? FQDN is fully qualified domain name. For example, if you have an IP, it would have a fully qualified domain name, for example, a host name of the computer itself. So whatever name an IP address would have, we call it a fully qualified domain name dot the domain name. So whatever we call it, whatever PC that we have on the network, if the domain is abc.com, the PC that we'll have on the network would be, as the name of the computer is host, it would be host.abc.com. So that would be a complete domain name of the machine. So if you'll ping either the fully qualified domain name or the IP address, you'll get the same results. Now, network latency tests, several methods used to delay in network latency to determine host likely sniffer activity. It is possible to measure which of the machines are working harder. Hard workers are potential sniffer hosts. Now, we segregate the traffic on the network based on the performance and based on the tasks. For example, in the networking course, we covered that we have virtual LANs. There are lots of reasons of having virtual LAN. First of all, you want to segregate the traffic from one segment to another. If something is dedicated for students, you keep them in a separate VLAN. If you have faculty, you keep them on a separate VLAN. If you have IP telephones, VoIP communications, you keep them in a separate VLAN. And if you have surveillance cameras on the network, we keep them in a separate VLAN. The reason is that some of these devices are quite noisy on the network, and if they are noisy, they would generate a lot of traffic on the network, and you don't want unnecessarily that the surveillance cameras traffic is affecting the communication of normal users. So we create a separate VLAN for the surveillance cameras because they are constantly uploading the images and the videos which are being captured on the network, and there is a lot of traffic for that. So you'll have to check that which are the most noisiest clients on the network. If you're not segregating them on the network, it would be difficult for you to judge that if someone is sniffing your network, or these are the VoIP telephones or the surveillance cameras which are creating a lot of traffic on the network. So that's why we have latency tests in order to make sure that there are no noisy computers on the network. If, for example, you'll check your network, the speed test between two computers for the data transfer and latency, etc., you'll get a response time of each packet, that how much time it took in order to reach the destination. If it's more than 1 ms, it means that there are some computers which are either sniffing the network, or they are affected with virus, or they are generating lots of traffic on the network. You'll have to identify those machines and then investigate them, make sure they are isolated from the network, just to make sure that they are not performing any malicious activity on the network. Now, ping test uses an anti-sniff to perform this test. Anti-sniff can send a packet that contains a legitimate IP address but a fake MAC address. Its host responds to the ping with a fake MAC address. It must mean that the host is in the promiscuous mode, means that the host is listening to all traffic and is responding to whatever it's receiving. Now, ARP test, which is the address resolution protocol, when in promiscuous mode, the Windows driver for the network examines only the first octet of the MAC address to determine whether it is in a broadcast packet mode. The anti-sniff can send a packet with a MAC address of, for example, this FF00 and the correct destination of the IP address to the host, causing the operating system to respond while in promiscuous mode. Now, as you can see, the MAC address which is shown FF0000 and these, what do you see by this one? It's not IP version 4. It's obvious, it's IP version 6 address. Now, it's sending it through a MAC address and correct destination of the IP address just to check that if it's in the promiscuous mode. Now, source route method uses a technique known as lose source, route to local sniffers or nearby network segments, adds the source route information inside the IP header of the packets. Routers ignore the destination address and forward the packets to the next IP address, so anyone on the network can see traffic for each other. Whereas if it was dedicated or directed to a specific MAC address, it won't communicate with the other computers and it would directly go to the machine where it's intended to. Now, the decoy method involves setting up a client and a server on either side of the network. Server is configured with accounts that do not have rights and privileges, or the server is virtual. Client using a script to log on to the servers using the telnet, POP, or IMAP protocol. Telnet, we know it's used in order to communicate with the other devices. Now, POP and IMAP are Microsoft Exchange protocols for mail delivery. Hackers can grab the username and password from the Ethernet and can prompt the log into the server. Now, in order to do that, we configure the mail servers, which is Exchange server, on the network on secure protocols or different ports which are secure as compared to the default ones which are there. Now, if you want to check that if you are running a promiscuous mode, that's a ifconfig, but ifconfig is a command which is used in Kali Linux or Unix platforms. Now, check if you are running a sniffer to your own computer. There are some tools with the help of which you can put your Mac or the network adapter in a promiscuous mode in Windows as well, but those programs are not available for free. Whereas on Kali Linux, you can easily do it through a terminal window. Now, protecting against a sniffer, the heart of defense against a sniffer is to make a data inconvenient to use, encourage to use of applications that use standard base encryption such as SSL, secure socket layer, or pretty good privacy, PGP, and the service multipurpose internet exchange extensions, which is SMIME, or secure shell, which is SSH. So, as far as the exam or any sort of certifications are concerned, you must know what is SSL, what is MIME, and what is SSH. Now, SSH is designed by Netscape. Long time ago, we used to have Netscape browsers as well to browse the internet, but then they stopped working with that name, provided data security layer between application protocols like SSL, or we call it secure socket layer. Non-proprietary protocol providing data encryption, server authentication, message integrity, and client authentication for TCP/IP communication, just making sure that the traffic which flows on the network is secure and it's encrypted. SSL is built-in security standard into web browsers, or SSL comes in into 40-bit or 128-bit. Pretty good privacy, PGP, or secure multipurpose internet mail extension, is for the email messages, etc. Basic requirement for the email is privacy and authentication, so your emails and authentication data is not being leaked out. Method that ensures the security of the email is SMIME, and Secure Shell is a secure alternative to Telnet. SSH protects you against IP spoofing, spoof attacks on the local network, IP source routing, DNS spoofing, interception of clear text, and man-in-the-middle attacks, which we call it MIME as well. Now, more protection is on OSI layer 2, enables the port security on a switch, and forces static ARP. ARP is Address Resolution Protocol. OSI layer 3, IPsec, paired with the secure authentication naming device, DNS security, and then firewalls can be mixed blessings. Sniffers are the most effective behind a firewall, where legacy clear text protocols are often allowed by corporate security policy. And that brings us to the end of chapter number 4.